Good morning. Welcome to this session on sustainable solutions in computer-aided engineering. We call it CAE, in short CAE. This is designing for a greener future through simulation. I want to bring an overview for this part, and then we will proceed in the next session to introduce how can we use these design softwares to help us in producing solutions which are sustainable for our future generation. Computer-aided engineering involves the use of software for the purpose of doing analysis and simulation, and then you optimize to give a solution that is sustaining. Normally, you can do analytical or mathematical modeling. Maybe you optimize design. If you say optimize, you can do differentiation. You can do integration using mathematical models. You can do approximation of errors using Runge-Kutta or using what we call Newton-Raphson method or other methods like bisection method in mathematics, so that you can get these values. Or you can also do what we call analysis or stress analysis. Then these values, they have become analytical in the sense that now you can use softwares to help you do simulations. When you say sustainability in CAE, it means you are designing products, you are designing systems or processes that minimize the use of energy or reduce the material wastage, or they normally enhance environmental or social or economic benefits across different entities. So some of these softwares, we have what we call ANSYS, SolidWorks, COMSOL, CATIA, Siemens NX, Abagas. There are so many of them. The traditional way of designing was they were making a prototype and then they make a change on the physical product before it is actualized. But the system has changed. You can design products in these softwares, then you analyze to see how this system will react to or will behave within the real world scenario. That is what we call computer-aided engineering. The reason why we use this computer-aided engineering in a normal setting or engineering. So this is very important as a designer. Why do we need CAE in engineering? Not just engineering, sustainable engineering. Something that can take us for years, something can ensure that it is efficient, it is effective, it is using less material, it is emitting less carbon. So why do we use CAE? Number one is normally about the weight. When you're designing, always you're looking at the weight of the output or the weight of the product or the weight of the system. CAE or computer-aided engineering normally helps to reduce the weight of the components, because when you are optimizing, there are places which will tell you need to reduce this material, you need to change this material, you need to reduce maybe the thickness or the diameter or maybe the size or the length. So CAE normally helps to reduce the weight of the components through what we call topology optimization, which at the end of the day, it leads to lower material usage and improved efficiency. So that is the purpose of using CAE in our design. Number two, it helps to improve energy efficiency, because you're able to do what we call thermal and fluid flow simulations. Thermal and fluid flow simulations will always help to optimize systems, like if you're using systems like heating, ventilation and air conditioning, or engines, to maximize energy conservation. So you can do thermal and fluid analysis to ensure that you save energy. Because you're also designing these systems to save energy, it means that you are selecting the right material for the right usage within the domain of engineering. And then we also have what we call life cycle. Computer-aided engineering, that is a simulation or design simulation and analysis softwares. They normally integrate what we call LCA tools into our simulations, so to ensure that LCA tools, these are called life cycle analysis tools, to ensure that we are simulating to the real world environment before we manufacture, which means wherever we are subjecting to this real world scenario or real world environment, their behavior will help us to predict their life cycle or the duration in terms of the usage. Number 4, computer aided engineering, they normally help us to predict a failure, because there's something called design for analysis or design for failure and manufacturing. So when you're designing for failure and manufacturing, it always help us to understand the fatigue and the stress simulations that will prevent premature failure or extend the product lifespan. So this computer aided engineering is very important. If you do a stress analysis, you're able to understand at which point will this product fail, so that you give a report that is needed for somebody who's going to use that product or that system, to understand that you only load or only use this system to a certain limit, so that they don't overload, and this one will help to extend the life cycle of a product. And this is what we call sustainable solution engineering. Then lastly is about renewable energy. Computer aided engineering normally will help us to design systems like solar panels, wind turbines, hydropower systems. These systems will help us to minimize or even maximize efficiency, because they are renewable in the sense that we are using whatever is available, not affecting the environment. So that is the purpose of computer-aided engineering. Let's look at some of the key tools or methods we can integrate in our computer-aided engineering for the purpose of making sustainable. Because we cannot just say something is sustaining. How is it sustaining? There are various methods or tools or gadgets that we can use to ensure that the system you are using are sustainable. What are the key sustainable computer-aided engineering tools and methods? Number 1, what we call finite element analysis. The word finite is minute. It means it's small. An example is when you go to hospital, you are sick. Maybe the doctor may tell you go to the lab. They give you to maybe those small gadgets. They tell you to give them the stool or the urine, in small quantities. They go and do a test. The test they get will represent what is affecting you, because it will give a report, so the doctor is able to understand what is ailing you. So the same way in engineering, before us subjecting our product to the environment, we must understand how will this product behave, what will cause it to fail. So we take a small specimen, then we subdivide into minute elements, and then from there we do an analysis. The same way we are doing mathematical modeling, maybe differentiation, integration, maybe approximation of errors using Runge-Kutta or using Newton-Raphson method. So this one we also do an analysis in softwares. So when you analyze stress, when you analyze strain, and when you also analyze deformation, either using volumetrics or using Tesla method or whatever Tesla method, other methods that are there, it will always help us to minimize the material usage. So this is the one of the key systems or key tools or key methods you can use in our sustainable computer-aided engineering. Number 2, we have what we call CFD. CFD is what we call computational fluid dynamics. We can also simulate heat transfer, airflow, and fluid dynamics. So this one will help us to understand the efficiency of the system, how it will interact when it being subjected to heat changes, when it is being subject to airflow or aerodynamics. So this is what we call computational fluid dynamics. Like aeroplanes, now the vehicles have streamlined bodies, aeroplanes have streamlined bodies. So this one will help us to understand how we're going to ensure that we design systems which are efficient. Number 3, we have what we call topological optimization. We have to use what we call an algorithm which is driven by the design to remove unnecessary materials. Maybe the thickness that we don't want, the sizes of even the shape. All this topology optimization will help us to ensure that we remove unnecessary material. At the same time, we are maintaining the strength of the design. Then we have another parameter called multiphysics simulation. We have a software called multiphysics console, which is normally done, or even ANSYS, which normally is the best to use when you're doing a simulation, like the multiphysics simulation. Which this one normally combines aspect like mechanical, aspect like thermal, aspect like fluid, and aspect like electrical. Because when you say multi, it is many. So you are combining mechanical aspect, thermal aspect, fluid aspect, and electrical to do a simulation. So this one it helps you in a wide perspective to understand all these factors coming from mechanical, thermal, fluid, and electrical. So that when you're giving out a report, you're giving out a report which is more efficient. Then lastly, we have what we call additive manufacturing. So these are some of the tools you can integrate in your computer-aided engineering to understand how you're going to give a sustainable solution in your design. Additive manufacturing is about 3D printing. You producing something like you're adding. So you want to optimize parts like 3D printing to reduce wastage of materials. As compared to machining. If you say CNC machining, you are subtracting, you are removing material from, and this one normally gives a lot of waste. But you are using 3D printing, you are adding material on top of another layer. So this one helps us to create products which are sustainable. At the same time, it helps us to ensure that we minimize wastage of material as compared to CNC machining. Okay. We have another aspect of what we call key examples of applications. Let's look at some of the applications of computer-aided engineering for sustainable solutions. Where can we apply these areas? Number one, green building design. You can do green building design like heat, ventilation, and air conditioning system or optimization, which will help us to reduce energy consumption, at the same time improve the computational fluid dynamics for the natural ventilation studies. Number two, we can apply these sustainable solutions through computer-aided engineering in sustainable transport. In the sense that we can produce aerodynamic vehicles, we can produce aerodynamic airplanes, which are using battery systems to ensure that they don't emit carbon emissions into the environment. At the same time, they are efficient in the sense that we are conserving energy across all these transport. So this is what we call sustainable transport. Then we have manufacturing processes. So we can also apply manufacturing processes. You do what we call computer integrated manufacturing, so that you model your system in such a way that the smooth flow of work from CAD comes to CNC, and then at the same time, when you are using computer-aided manufacturing, you are simulating the flow of your work to understand that you are going to reduce defects or bottlenecks across the manufacturing system as you move from one point to another. Like you can apply in mold making mold tools, maybe blow mold or injection mold, or maybe making dies. You can apply these systems to ensure that you produce sustainable solutions for the future use. Then last application, there are so many of them. Last application, you can also do simulation of the hydropower turbines and solar water heaters for the higher energy efficient. When you do a simulation, it will help you to understand where can you make a change, where can you optimize energy, where can you conserve energy, and where can you harness more energy for the purpose of ensuring that the energy is harnessed, is of high intensity, and it is of high use. So this is what we call sustainable solutions in computer-aided engineering. What are the benefits of us using computer-aided engineering in sustainability? Number one is it reduces physical prototyping. Because every time you're doing a simulation, all the problems you are facing, you are removing them from the design. If it gives you any errors, you remove them from the design before you do physical prototyping, which means when you do a simulation, a high chance is you are reducing physical prototyping, which may be costly. At the same time, you are reducing wastage of materials. Number two, there is lower energy use in the design and production because you are optimizing the systems. If you are using the heating, ventilation and air conditioning systems, or you are using solar systems, you do thermal analysis, you do fluid analysis. At the end of the day, you have optimized the system and you have reduced energy usage in that system or energy wastage. 3, you are saving cost. As I said, if you're doing physical, if you're doing software simulation, it's like you're also already doing software prototyping. So the cost of doing physical prototyping is reduced. Even material wastage is reduced. So you are cost saving through material efficiency. Number 4, you are enhancing durability. You are able to understand the design for failure and manufacturing, at which point will this the system fail when you subject it to real world scenario as vis-a-vis when you're doing your analysis. So this one helps us to enhance durability, ensure the product will last longer, and you are reducing the replacement cycle, so that this helps us to improve sustainability. Then you have what we call eco-friendly innovations. If you're able to do analysis or simulations, you provide systems which are efficient, which are friendly to the environment. That's what you call eco-friendly. They are friendly to the environment. They don't emit carbon emissions. At the same time, they use maybe or they support what we call renewable energy systems and green construction. That is the purpose of using computer-aided engineering in sustainability. What are the challenges that may occur in sustainable computer-aided engineering? Number 1 is high cost. When you're doing these simulations, you need advanced computer-aided engineering softwares and computing resources, which means they may be expensive because these softwares runs on high-end computers. Not just normal computers. You need a powerful computer and need an advanced software to do this, which are very expensive. So you have to incur a cost in these softwares for it to work with what you need to achieve. Number 2, it also needs a skilled workforce. Somebody who has never gone to school cannot do these simulations. You have to go to learn engineering that suits your field. You have to understand all the scenarios of designing for industry, so that when you're using these skills, it is you are giving a result or an output which is standard. So this one requires engineers to be trained in both sustainability principles and simulation techniques, and which is very few in most of the engineering perspective in Kenya. Number 3, it requires integration database with the environment, because if you are integrating the environmental tools to the CAE, it may be a challenge because it may take time for you to develop it. That's why some of these tools are still under development to integrate these issues of the water environment database into the system of computer-aided engineering softwares. Then last is about accuracy and time. For you to give an accurate result, one, balancing simulation accuracy with the computational time for large products may seem a challenge, because it requires a high-end computer. It may take time to run to give you an accurate result. So if you're not patient, if your computer is not powerful, and if you're not skilled, accuracy will not be achieved. That is the challenges when you're using sustainable solutions in computer-aided engineering. What are the future trends in sustainable computer-aided engineering? These are the trends which are now coming up. The AI and machine learning. We are using, like guys who are using CNC, they are programming. Others are using manual way programming. Others are using computer. But AI has now come in to advanced machine learning. People are designing robots. People are using this AI to program their CNC machines. Even some of these CNC machines have robot inside. They have AI language inside. So faster design optimization for eco-friendly solutions are now what is taking shape in the industry. Number 2, cloud-based computer CAE, like Fusion 360, like CREA PTC, like OnShape. These softwares have changed their perspective. You don't need to install in your computer. You just need to create an account online, and then you use their softwares, which means they are using cloud-based way of sharing resources to reduce infrastructure cost and also to reduce carbon footprint. Number 3, what you call digital twins. There is what you call real-time monitoring and simulation for the predictive maintenance. So they have put some features that predicts or monitors the real-time predictability for the maintenance, so that you are able to understand how you are going to monitor your system within the generative design. Then lastly is about automation. So automated eco design using this system sometimes may be constrained, but these are the future trends that are coming in to ensure that systems work with the CAE. Last, about the summary of this. I know I've given you just a preview. This is a preview of what we intend to do in our next session of computer engineering and computer-aided engineering. Computer-aided engineering is a powerful tool. It's a powerful enabler. It's a powerful gadget that will power sustainability in industrial design and production. Simply because it will reduce the wastage of material, it will improve the energy efficiency, it will extend the product life cycle, and it will support renewable energy technologies by integrating them into some of the tools that are coming up, like a finite element analysis or finite element method, computational fluid dynamics, topology optimization, and multi-physics simulations. So engineers are required to understand. They are required to understand sustainability tools. They are required to go to colleges or universities to learn these tools, understand how they are going to use them. Although they are cost effective, they are environmentally friendly, and they ensure that at the end of the day, solutions are arrived at. The future of engineering is sustainable, but without prior knowledge, without prior training, you may not achieve what you need to achieve. Computer-aided engineering is the leading problem solver in our industry in terms of engineering design and product, and it's the best tool you can use in your research. I think Africa, we have not invested a lot in research. I know South Africa, Namibia, Morocco, they are doing a lot of research in industrial design and production. But some of other countries, we are slow in terms of in terms of research. That's why some of these tools may not be so used in these scenarios. But it is good to use these tools to prevent the collapse of houses, to prevent the failure of vehicles, to prevent the failure of systems, components, or gadgets that have been meant for the purpose of solving problems in the real world scenario. So thank you and have a lovely day. Next, we will go to the software to understand how can we use this system physically to demonstrate the power of computer-aided engineering. Thank you. Have a lovely day.